In this video, we will explore how large language models are deployed. By the end of this video, you will learn how LLM development is different from traditional machine learning, examine the three different types of LLMs, and discuss the chain of thought reasoning concept to design better LLM prompts. Okay, let's dive deeper. Traditional machine learning involves extensive technical expertise, massive training data, complex model training, and some hardware knowledge for computing resource management. LLM development instead centers on crafting effective prompts. No technical background required. The focus is on clear, concise, and informative prompts rather than the details and nuances of model design and training. There are three primary categories of LLMs based on their functionality: generic, instruction-tuned, and dialog-tuned. Generic language models. These models predict the subsequent words like an autocomplete feature. Their predictions are purely based on linguistic patterns they find in their training data. Instruction-tuned models generate responses based on specific instructions embedded in the input prompts. They can summarize, compose poetry, analyze sentiments, and a lot more. Dialog-tuned models are specialized subsets of LLMs focused on conversational interactions, something we commonly see in chatbots. This is the type of LLM that I chose to demo in this course. An interesting concept in LLM is chain of thought reasoning. In chain of thought reasoning, the model generates a reasoning chain before concluding and providing an answer. It's similar to how we break down a problem into smaller pieces in order to understand it better. To get a better idea, let's ask ChatGPT for an example. So I went ahead and asked ChatGPT, give me an example of how an LLM can process a complex prompt using chain of thought reasoning. This is the response that it provided. So the prompt is, imagine a city where all the buildings are made of transparent material. How would this affect the lives of people living there, the energy consumption of the buildings, and the overall urban design? So this is what would happen in the background. The LLM would break the problem into smaller pieces and try to look at it from different perspectives. For this example, it could be the relationship between transparent buildings and privacy, or light and energy consumption, or aesthetics and urban atmosphere, or safety and security. So after considering all these perspectives, the model goes ahead and produces a final response. In this example, the LLM breaks down the prompt into different aspects, for example, privacy, energy consumption, aesthetics, and safety. Then, it analyzes the effects on people and urban design for each aspect, and finally combines all this information to provide a comprehensive response. Now, let's look at some key considerations for crafting effective LLM prompts. Frame prompts as clear, concise instructions tailored to the model. Leverage the model's strengths and limitations. Start with simple prompts. Increase the complexity gradually. And keep experimenting to learn optimal phrasing and structures that work better. In conclusion, LLM development is different from traditional machine learning by prioritizing well-designed prompts over technical complexities. LLMs come in three main varieties: generic, instruction-tuned, and dialog-tuned. And it's important to know that concepts like chain of thought reasoning enhance LLM capabilities to generate more accurate and coherent responses by systematically working through the steps of a problem or argument.